Hello, and welcome to yet another episode of Tag1 Team Talks. I'm your host, Preston So, Editor-in-Chief here at Tag1 Consulting and the author of Decoupled Drupal in Practice. Today, we're going to be talking about YJS offline apps with IndexedDB during this webinar and podcast series about emerging web technologies, of course. One of the things that we always like to mention on the show at the very beginning is you can check out our past talks at tag1.com/tagteamtalks. And if you like this webinar session today, please remember to upvote, subscribe, and share it with your family and friends. Today we've got an amazing cast of characters on our webinar. First of all, I'd like to introduce our special guest, Kevin Jans, the creator of YJS. He's based out of Berlin, Germany currently. He's the founder and project lead of YJS and the real-time collaboration systems lead at Tag1. We've also got with us our dear friend, Fabian Franz, Senior Technical Architect and Performance Lead at Tag1. Fabian is, of course, one of the 5 Drupal 7 core branch maintainers. He's also one of the top 50 contributors to Drupal 8 and maintainer for several Drupal 8 core subsystems, including BigPipe, Dynamic Page Cache, and Theme API. And finally, we're joined by our good friend, Michael Myers, Managing Director at Tag1. Michael, do you want to kick us off with a little bit of a description about Tag1 and why we're all interested in this topic?
Awesome. Thanks, guys. Really appreciate you being here with us today. So Tag1 is a web development consulting company specialized in infrastructure, software development. We've been doing a lot of projects that involve real-time collaboration. We're excited to be doing more work with Kevin on these projects. I think we're going to see real-time collaboration become a key part of web applications, or all applications for that matter, moving forward, enabling people in a workforce to work together in real time is how business gets done. So, for example, with content management systems like Drupal and WordPress, which we do a lot of work with, enabling content editors to edit rich text, to create documents together in real time, to work on layouts and page setups in real time together. This should be a component of every modern CMS system. And so that's the stuff we're going to be talking about today, is how we're making that happen.
I absolutely agree. I think that being able to edit offline is a huge feature that a lot of CMSs need. And here to join us today to talk about this, a very important topic, is Kevin Jans. Hey, Kevin. Such a pleasure to see you again on the program. Can you tell us right away, what is an offline app and why is this so important?
Right. Thanks for that. Hi. Yeah, so ever since the web was created, we have misused the web to create web applications, right? We use web applications because they are always available on all the devices and they sync to the cloud, which is really comfortable. But a huge disadvantage of the web was always that it is not available offline. So when you are in a train, on a plane, you just have a bad connection at a bad place. You can't access your favorite website or your favorite documents. Just imagine like you're offline and you really need to see what's in this Google Docs document. You can't really see it because it's not available offline. So that's the huge advantage of offline apps. And there are some apps now emerging from the web that are also work offline. And there's a technology, Serviceworkers, that makes this possible. And these apps get more and more complicated. So there are, for example, some blog websites that fetch the data in the background and just store them for you to see when you don't have internet connection. So you can read your article, you can read the next article even without an internet connection, which is really comfortable. And there are also more complicated apps like Twitter that work offline, fetch data in the background, and you can tweet away, and these tweets that you create while offline, they're just later synced as soon as you have an internet connection again. So for me, this is really interesting time right now.
So one of the things I think a lot of Tag1 Team Talks' viewers have seen is that there's a proliferation of online applications on the web really emerging, but we're also hearing, this new marketing technique. I hear a lot of people, not only in my spheres, but I've done this myself as well, talk about a lot of the frameworks that are out there or apps that are out there as offline first. But what does offline first really mean? Is that different from offline enabled?
Yeah, I think so. I think you can categorize them as following, like offline enabled or like offline as a progressive enhancement just means that some parts of the application still work while offline. And a good example for this is a lot of websites that just show a different website when you're offline. For example, sorry, we are offline right now. We can't really do anything for you. But some of them show limited functionality. And some handle the case of offline really graciously. So for example, Twitter on the website, when you open the Twitter website and you lose internet connection and you post a tweet, this tweet will be stored in a local database when you don't have the internet connection. And later when you are online, it is sent to the server. But the whole Twitter app, of course, with all these tweets is not available offline. But some of the tweets are fetched and you can even see a lot of the tweets while offline. You don't need an internet connection for that. So there's limited functionality. Offline first, in comparison, is your whole application works offline as well as it does online. That's how I would categorize it. A good example for that is maybe Google Docs with a native plugin. On Chrome OS, for example, you can use Google Docs while offline completely. There's not a problem. It's really cool. Even the changes that you do are later synced to their platform. Blogs are often, they're so simple because it's just a website that you show. So there's basically a background job that checks if you have internet connection, it will serve the latest content to you. And if you don't have internet connection, it will save the content that is stored in a local database to you, or even, yeah. So yeah, this is how I would categorize it. And here's a fun thing. There are also offline only applications. Just search for it. There are applications that only work while offline to keep you from all the distractions of the internet.
Well, I, for one, can certainly use an offline-only application when I have trouble focusing. Okay, so I think that this really helps us. You know, this spectrum between offline-enabled, offline-first, and offline-only, very, very interesting. I think that this emergence of all of this spectrum is going to be really important to the next few years. But let's talk a little bit about how this actually works from the technical standpoint. When we say offline, and we're talking about a web application, how does offline actually work on the web? And let's talk a little bit about some of the technologies involved there.
Right. So the technology that makes this possible is our Serviceworkers and IndexedDB. IndexedDB is a local database in the browser that you can use to store anything. For example, websites, the content of a website. And a service worker is a really interesting technology. It basically sits in the background of your website and can intercept all the requests, all the network requests that you do from the website. So this is a browser technology. It has started one process for each website, and it can intercept all the network requests, and it can do anything with it. So for example, you can check if you have internet access and then grab the latest state of your website, just fetch all the content with all the dependencies, the CSS stored in a database, and then serve the content that you have to the website. So your website will still work if it doesn't support service workers, but if service workers are supported, it will intercept the requests and serve you different content or even the same content, but also offline. Another advantage is if you configure this service worker correctly, you can make your web app much faster. There's, for example, this first cache first technology. Like the idea here is instead of always using the network requests, you always serve what you have in a local database first, and you update your local database. And this is, for example, something I use on yjs.dev. It's a cache-first website, so in the background, it always fetches the latest state. But as soon as the website really loads very fast, because it will serve the content that it has on offline in a database. So that's basically it. This is the technology that we have, but of course there's so many problems that we need to figure out. For example, the UI patterns and how that works, the syncing of the background data. Yeah.
Yeah, I quickly want to go into that topic again. It's a kind of technique in caching. It's we validate while stale. That's how it's called in its technical term. That means whenever someone comes to you and wants data, you send them whatever you have. And then you check this, for example, within a CDN like Fastly, like Varnish, like Cloudflare. And then while you're doing this and the user is already happily browsing the website with all the things, etc., you check, hey, server, might there be a new version of this? And then the server says, hey, yes, there is. And then you store it in the cache. And the next time a user comes, they get automatically the fresh version in that. So, of course, usually there's, from a caching perspective, there's like a timeout in that, like you don't want to serve content longer than 24 hours or something like that, because it could lead to very few confusions in that. But that's generally the idea of revalidate while stale. That if you still have a version, and as long as you have many visitors, it doesn't really matter if someone gets the new cached version 10 seconds faster than someone else, everyone will still have a fast experience, while the server in the background is happily reproducing, recreating the website, and is then giving out the new information. And this is basically the idea of putting, so it's for those familiar with more the CDN terms, etc., you can also think of a service worker as your own personal CDN is in the browser of the user. It actually Cloud first supports service workers on the cloud, so it's kind of funny they kind of took this approach and put it back in the CDN, so it's even more connected now. But yeah, that's how you can think about it. You have your own CDN basically as a layer within the user's browser, and you can do whatever you want there.
You said IndexedDB, so this is some kind of database technology. I assume it's not like Oracle embedded in your browser. Is this is this a SQL database? How do you query it? Can you tell us a little bit more about that?
Yeah, IndexedDB is an object storage. It is basically an evolved version of LevelDB that Google developed just for not really a database that you start on your own, but a database that is embedded in your application. And in this case, it is embedded into the browser. And each website has access to one IndexedDB database, and it can query. It has limited query functionality. It is not as powerful as SQL, but it is very fast, and you can implement basically anything with it. And yeah, and the service worker uses IndexedDB in the background to store the website. So it has a context to store websites or resources, basically anything. And it can access this database to retrieve other content and serve it to the client.
When we did our WebRTC webinar, Tag TeamTalk last week, you talked about end-to-end encryption and how with WebRTC it's encrypted by default. It sounds like with IndexedDB I can't access databases for other sites. How is that information stored on my local computer, though? Is it encrypted by default? Can it be encrypted? What kind of security mechanisms are in place for that?
Honestly, I don't know. I think on your local computer, probably everyone can read it who has access to your account. So it is protected by your operations system, whatever encryption mechanism you use, or if you use any. But aside from that, of course, the browser doesn't encrypt the database. Of course, you could, if you want, create your own encryption mechanism. There are examples for that. For example, some password managers use IndexedDB to store the passwords and make them available while offline. but you need a key to process that. And IndexedDB is really really interesting technology because you can even store keys like RSH keys in a very secure manner, so that your application can't access the content of the key and can't send the key to other people, but you can store the key so you can have access it and decrypt things. So there's a lot of thought put into this, and I am not an expert on that, but I can certainly say that you can implement secure applications with it.
Wonderful. And one of the things that I think is really important to stress for our audience today is that not only are we talking about offline first applications as being something where you have access to all of this data offline, it also improves the end user performance because you're constantly fetching from the cache. And I think that's just a very important thing to call out for the audience who might be less familiar with how this can enable that really quick time to first paint as well in the browser. So let's move a little bit to topics that we know about, that we really play with on a daily basis, like YJS. As I understand it, YJS is a topic we've covered many times on this channel, on this series, and it's a real-time collaboration framework that's open source. How does it support offline editing?
Yeah, so yeah, the idea is just stores the document offline, right? And there's even more, there's a lot of interesting things with IndexedDB and YJS because, well, to start again, I created recently the IndexedDB adapter for YJS, which enables you to store your document in the local IndexedDB database, but also store document updates very efficiently. So you can retrieve it very fast, and also handles the case of concurrency when you have multiple pages open that access the same database. They can all access the same database, retrieve the information, share the content through the database, which is really interesting and something that you want, because often you want to have often you have different browser tabs open accessing the same content, and they need to be able to communicate with each other. So this is why IndexedDB enables you. Even while offline, your browser tabs can communicate with each other and store document updates. And instead of storing the whole document as a big binary blob every time you make a change, you only store small increments of the data to the database. And when you reload your page, it just accesses the IndexedDB database and retrieves the document again.
Just to give a very practical example, assume you have 3,500 tabs open in a browser, and you work a lot with your CMS, and you do things, and you edit content, and then you go away and have a nice day outside, and you come back and you continue working, and you totally forgot that you had this article open in your Drupal CMS. And then you go back to your CMS, log in, edit the content, and it's all there. Everything you've changed already on the content is all there automatically. You don't need to do anything. And even if you now change it here and save it, then you go back to your basically your other draft, in that then automatically it has all changed there already. You already see all your changes there, and that you already saved it, etc. So even if you forget, you don't have conflicts, you don't have things to, oh, how did I do this? I need to reproduce this here, etc. And even in another case, assume we would have had this for like Drupal.org issues. You're working on a few issues, writing long text, etc. Computer crashes, browser crashes, power goes off, whatever happens, all is lost in that. You haven't submitted yet, and you've worked 1 freaking hour on it. If you had attached this to a Y instance with Y IndexedDB, it's all there. you just come back, you can continue working like you never had been away in that. So it can also help save data in that, that you never lose any content in that. And that's very, very great in that, because it's a problem. I mean, we have autosave in Drupal, for example, as a module which frequently saves, like every 300 milliseconds, but it saves to a server. So what happens when you're offline? You can't save in that. And obviously, we also have some where we try to put it in like local storage in that. And that works a little bit, but it doesn't really help with the cases of you make up this other tab of the same content, etc. And it's really nice that this with YJS can just works.
Right, and here's another use case. You talked about the crashing of your local browser or like losing your internet connection. Just imagine you go in a plane and, oh man, I need to have this tab open now until I can sync the content to the server. Now what you can do is, because Serviceworkers also have access to your IndexedDB database, as soon as you have access to the internet again, the browser will start your service worker even when your website isn't open. And you can sync the content to your server and persist it so other applications can also see what you created. So what this really allows you is to create offline first applications that gracefully sync, but also enable you to progressively enhance your application, because now your content will be available immediately after you open the website. In the case of a Drupal document that is collaboratively edited, you start your CMS and you immediately see the content popping up, because it doesn't need to wait for the server. It will serve it from a local database, and also the amount of data that needs to be synced is reduced because YJS already supports differential synchronization. So instead of exchanging the whole document, it will only exchange the parts that changed. So the server will send you a small update of the content that was created by other users, and you will send to the server the content that you created. So in that regard, IndexedDB is a really nice enhancement to your application, regardless if you want to create an offline application. It is just there to improve the performance of your web application.
So YJS is basically perfect for James Bond. Like in this scenario, they need to send some very important information they have to that, but there's no internet in that. But they know this track will eventually have internet, even if James Bond has gone off the rails already, but this laptop is still there. But as soon as it gains back the internet content, it will sync the data, and then all is safe.
All right, awesome example. YJS is for James Bond. Let's keep it at that.
I think we can all agree that some of these features are very much secret agent features and very futuristic. So we've talked a little bit about why IndexedDB in terms of that adapter for YJS. How does this exactly tie to Webworkers, though?
I mean, it is not really tied to it. It does work in conjunction with Serviceworkers.
Oh, okay, sorry.
Yeah, no.
Maybe we should cut that. Maybe we should cut that question out.
Awesome question, because there are also Webworkers, which is a completely different thing. And
okay.
So Service Worker is a job that sits in the background and intercepts your HTTP requests. But Webworkers are just background jobs that you can start, for example, to do heavy calculations. And with IndexedDB and Webworkers, actually, accidentally, this is an awesome question, you can do really awesome things. For example, if you want to do some heavy calculations on your YJS document, you can start a web worker that fetches the YJS document from the IndexedDB database and then does these calculations, maybe do a very expensive sync job with the server, or I don't know, For example, you want to render an HTML page based on the data that is in the YJS document, and then send it back to the main thread. So Webworkers allow you to do heavy calculations, and IndexedDB allows you to exchange data with Serviceworkers or the web worker very efficiently, basically with all the browser contexts, because IndexedDB is shared between all the browser contexts. It's basically the ideal database that multiple processes can access concurrently, and they can use it to do different things. For example, the service worker might want to create a WebSocket connection to the server to sync the data, or even use a different technology to sync the data to persist it in the web and the cloud, wherever. And the main thread, your website, doesn't really need to do that much, and it doesn't need to be open to sync the content.
Yeah, I think that's a very important thing. This thing how Webworkers pull into this is that synchronization, especially if you have lots of changes on the server, lots of changes on your local, they all need to be synced conflict-free, which YJS can do. It still takes a while. And the thing is, as a user, you don't want to wait for the while, so you don't want to have like a spinning circle. Syncing data, you can start working in 10 minutes, you can start working in 9 minutes, you can start working in 8 minutes. Hopefully it doesn't take that long, but anyway, you get the idea. So if you put all of that into Webworker, then you can already start working on your document. You can see live changes that are already happening in that, that have been synced, and that all happens in the background. So basically, a Webworker gives you a different thread than the main thread where all the interaction with the user happens. So Webworkers are basically for not blocking the user interaction, which is very, very important, because as we speak about real time and all of that, one of the most important things here is the responsibility, the responsiveness. Responsiveness, that means that the user really gets feedback really fast on every keystroke. So it's not like I click a key, then it gets sent to the server says, yes, you can write that key, and sends it back. And then I can click the next key in that. Because that's even how if you try some of the other technologies like Google Docs and others over low latency connection, it can happen in that. I had this happen in one of my tests that I did originally when I was comparing YJS with Google Docs. And suddenly I had a very, very, very slow Google Docs where I was clicking a key and it took like, I don't know, I think it took 3 or 4 seconds until that keystroke was registered, and I clicked the next key and it was like, so in that regard, Webworkers, IndexedDB, Serviceworkers, they play like a perfect triangle of things that are now available for us to build great offline apps.
You just gave me flashbacks, Fabian, to writing an email in Gmail. And you try and send it when you're offline and it gives you an error, or when I want to check my mail and it's like, we're going to retry in 5, 4, you know? So could YJS enable Gmail to work offline? Like I could write my emails, store them for submitting later when I'm back online?
I mean, I think you can do that without YJS, but as soon as you have a collaborative document, you need something like YJS, because so much can happen while offline. Other clients can edit the document, so you basically need a very involved synchronization framework. In the case of Google Docs document, I also remember that. I remember all the forms that I lost because my post request wasn't performed on the server because the server is unavailable or whatever. And I get a 404 and all the content that I created is lost. Now with service workers, what you can do is, instead of losing that content, the service worker will store the document, the request offline, send it later as soon as you have internet access. And the same goes for YJS documents, for collaborative documents, for your React app. You can share state with YJS, basically anything for your drawing app. Just store it in IndexedDB and let the service worker figure out when to sync the content to the server.
And basically that brings us to a very, very, very important point, because with Vue.js technology, we are changing from a traditional client-server model to one of synchronization. And that is very, 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 very key in all of this. And I'll explain why. The reason why this is so key is that, as Kevin said, usually when we have a traditional application built with React or whatever, you're doing state changes, and those state changes eventually go to the server, and that's usually done with the post. And if that fails, okay, the application can try again, etc. But imagine that you would not need to deal with any of that. You would just use like the Vue.js primitives, like a Y array. You would store that in, and you would now eventually it will sync to a server when there's connection, when there's everything in that. And that's a different way to think about data. It's no longer I have this data, I store it to the server, and I get my new state back from the server, but it's just I put my data in here and it's synchronized automatically. And there's a completely different way of thinking about applications, of thinking about data, how it gets in, how it gets out, etc. And that's why offline first with Vue.js is so key. And here not Vue.js as a text collaboration tool, but as a tool that's built up on data types, so that you can have a collaborative to-do list basically just by having a data structure that's collaborative. As soon as you put an item in there, it gets synced to the server, it gets synced to the other users that are collaborating on the to-do list automatically. And this is, in its own way, a kind of revolution.
Well put.
Absolutely. I think that the use cases that this enables will really reinvent the way that we interact with probably the vast majority of the applications we use that involve some level of collaboration really, really easily. I mean, I can just think of so many ways in which, for example, scheduling collaboratively could become easier with this kind of model. Very, very exciting. And so last time we got together as a group, we talked a little bit about this new communication protocol that allows for browser-based communication called WebRTC. And for those of you who are in the audience who are watching this or listening to this, do check out our WebRTC webinar, the Why WebRTC webinar episode, because that goes into a whole lot of detail about some of the really interesting features coming out because of that. So one question I had for you, Kevin, was how does this work in conjunction with Why WebRTC? And what sorts of ways can we combine these really interesting technologies together?
Yeah, that's an awesome question. I think the only downside of Why WebRTC, which allows you to basically, without a server, create a peer-to-peer network between all the clients that are interested in the same document. And the only downside of this is that it takes some time to create a connection to the other peers. And it takes some time to synchronize, because WebRTC, as soon as a connection is established, it is very fast. But creating connection, like establishing that connection, sometimes takes a while, especially on bad internet connections. So, and this fits together with why IndexedDB, because it allows you to store the document offline and serve it immediately without waiting for the other peers. And it also allows you to do some very interesting things. Just imagine our video chat application right now. There are a lot of WebRTC based chat applications on the web, for the web, that are accessible for everyone. Some of them allow you to collaborate on documents. Actually, I only know of one. And so with IndexedDB, now you can store the document offline. So the next time you open this, this chat room that you created for collaborating, for chatting, it is still there. And you don't need a server for this, because it is persisted locally and among all the other clients. And you can even sync with them, as we discussed, even if they don't have if they don't have the website open, because there are background jobs that can do that. So this allows for a lot of interesting technology, especially with WebRTC. I think it is necessary to have faster access to the document. And how you can do that is now by IndexedDB.
Very interesting. Let's talk a little bit about some of the kind of byproducts of all of this. How does this not result in an overload of garbage? You know, I think that this is a very important topic for when it comes to performance and scalability.
Right. I mean, there are two aspects here. The first one is how can you actually resolve all these conflicts? And yeah, I think we made a deep dive. I think the second deep dive, we go into detail how the conflict resolution actually figures out this stuff. We didn't figure out that, we didn't explain it in full detail or prove it, but there's a paper. Just go to the YJS GitHub repository. On the bottom, there's an explanation on how the conflicts are resolved. And here, very important is YJS was always a framework that does not need a server connection. It is network agnostic and doesn't need a unique order of the messages that are sent. It basically only listens to document updates, so it can always sync. As soon as your local document gets all the updates from the other peers, it is synced. There's no central instance that manages how your conflicts are resolved. This is all decentralized. And
yeah, and just to remind our audience a little bit about what we talked last time is that when we have WebRTC, we can have also partition. That means we are connected across the ocean. Michael in New York, Kevin and me here in Europe. Connection gets severed. There's no connection anymore between us. And that's basically, we are, at least from the relative standpoint out of each other, offline. And so that's why basically YJS already handled the offline case. It must. Every peer-to-peer application that is working in a way that it can sync changes after a connection is reestablished is basically offline in a way. And this just takes us further, that if we all close our connections down, the document is not lost because every one of us even have a copy of it in that. So let's say we are working on this document across the ocean and the network cable goes down, and we are all so frustrated, we all close our browsers. So, and now we start it up again, and no one would have a copy anymore. No one would have the changes anymore in that. But if I have my own copy and Kevin has his own copy and Michael has his own copy, then it can all sync up again as soon as, hey, network's back. Okay, let's fire it up again, and then it will automatically sync. So really, this why IndexedDB is just like it complements the WebRTC approach. It's basically, even in a way, for me, myself, a requirement that we have not only the capability to sync in real time, which is really nice for video, but also to store whatever we've worked on.
That's right. Yeah, I think that the second part of Preston's question was like as soon as you sync, there's also garbage that is there. Like, for example, if I created a lot of content, you created a lot of content, there's a lot of garbage, possibly. How do you actually figure out how to make a proper sync that makes sense to the human? In Git terms, yeah, how, like, if there are conflicts, how do you resolve them? If I fixed a typo in the document and Fabian, while offline or while not having a connection to me, also fixes the same issue, when the documents merge, we might end up with garbage, right? We discussed this in the Prose Mirror channel briefly. And one of the arguments against CRDTs is that you don't want to have that garbage. You want to have a central instance that manages and only serves one version of the document that makes sense and that was well proven to be correct by a human. And there is something that you can do against that, and that's YJS versions, which allow you to, as soon as you sync with the other clients, you can show the differences that happened while others were offline or while you were offline. And then by showing the differences between the changes that just came in, you can figure out, okay, Fabian also fixed this issue. Now we have the fix 2 times applied, which doesn't make sense anymore. I need to revert his change, or I can just edit his change. This is basically the same thing that you want to do when you do a git merge. You just figure out the differences and you apply the changes that happen concurrently and in a way that makes sense for the new state of the application. So
yeah, basically what YJS can do, just in a much more broader term, and that is, and we didn't talk about that, but it's so exciting. It's basically, if you know Drupal, it's revisions, then you know it. Basically, every time we do a change, we have like a revision, and that's in YJS called a state vector. So we have all the history of all time. So if the universe was built on YJS, then we could roll back to every point in time of the whole universe. It's Time Machine, basically, if you're a Mac fan. Where with Time Machine, you can also go back to every state that your hard disk was ever in, as long as you have space on your backup. Anyway, so because we have like all the history of all time in that, and in a more practical example, Michael and me are working on a document together. It's important, and he worked offline, and then and I worked offline. Then our changes sync, and we have 2 paragraphs that really don't fit together too well in that. And for that, we need someone like Preston, who's an editor, editor-in-chief, who can then untangle the mess, basically. But what happens if it's within the sentences, and it really gets to garbage? So, and that's where YJS versions come in, basically, because Michael can see how my changes affected his version, and I can see how his changes affected my version in that. And now the nicest thing about that is, and that's not implement, but Kevin can probably do it, is you could also rewrite history. Think about like a Git rebased interactive, where you basically rewriting the history. So Michael says, hey, this whole law that Fabian here wrote, that's cool, but I don't really need it. So he could go back to basically my version, in theory at least, take out that, copy it somewhere else, like stash it for later usage in some other document, then delete it so that I've never made these changes, basically. And then he would reapply basically those changes. And that basically would allow to see that. And with YJS, this is in theory possible because we have all the changes from everyone. We know what everyone changed, what character they changed. And even if you type like total garbage in that, Michael could just say, hey, this change, let's just take this version from me, and this is now the version again, and we'll just apply whatever came in there manually in that. So there's a lot of possibilities even without a central server to do that. And I think that's much more important because I do think in the end, every Git conflict, who resolves that? It's a human. It's a human. There are no machines doing that because they can't understand that machine learning is there. There's some approaches in that. But in the end, it's a human. And I think it's much more important to give a human the tools to do that. And YJS versions are such a tool. They can see all of this has changed since you last synced. And that's already available there. It's on the website. You can see it. It's great. It's really fantastic. You can even see how how the document is changing since you've been away in real time. It's really freaking awesome. It's one of the coolest features I've seen in that, and we'll definitely link it in that. But giving the human the tools is, in my opinion, the way. And the nice thing is, whenever we can automatically sync, we will. But whenever we can't, we can still involve a human. And I think that's much more empowering than to say, it needs to be a human anyway, so we do just a Git-like reconciliation approach.
Right. Well put. And by the way, this is really available on the yjs.dev website. Just give a quick overview here. YJS.dev now works with WebRTC, so there's no central instance that manages the content. And also, it has versioning support for the examples, or at least for the Prosemera example. So you can click on one of the versions, you can create versions, and you can actually see the differences that happened, why you were offline. So all of this is actually possible. The only thing that is missing is like create a UI for your application to show those differences. So for text documents and for Prosemera, this is almost been solved basically. But I think there are some UI things that you need to consider to do that, right? It's mostly an UI thing, but the framework possibilities are all there. They're all open source and they're ready to use right now.
Wonderful. And I think that's one of the things that I'm looking forward to checking out as soon as we hop off this episode. One of the things I wanted to ask was, are there any other challenges in offline shared editing that we haven't already mentioned? What are some of the other sorts of hidden or lesser known shared editing use cases that this particular approach around IndexedDB enables?
Oh yeah, I think the trickiest thing about offline editing is garbage collection. We talked about versions, that we want to jump back to previous versions, we want to save versions, and but how does that tie? Like if we store all the content that was ever created, our documents would blow up. In the case of the website yjs.dev, if I would store all the content that all the users that visit this website, if I would store that in the document size would get huge. There are people who copy Wikipedia articles and just put it there like 1,000 times, and the document can be really large. As soon as you delete content again, the content should be freed. But if we have versions, if we store all the content that was ever created, we can never delete that content from the YJS document. And now there's a method that allows you to garbage collect the content that was created in between versions. So this is really cool right now. You go on the website, you create a version. The content of that version will never be garbage collected. But if you insert a Wikipedia article and somebody else deletes that Wikipedia article again, the content is basically garbage collected and not be stored in the YJS document. So there's finely grained granularity that you can have on what content is actually deleted from the content, from the document.
Yeah, basically it's something we talked about early on of what optimizations YJS make that makes CRDTs feasible. Mm-hmm. And that's one of them.
Right.
And basically, to give another example from the Drupal world, here is, in Drupal 8 we now have forward revisions with workspaces. That means an editor can work on some article a long time. And once they are finally ready to publish it, they'll publish this article, and then it goes basically live. So, but now that they have like 20, 30, whatever, how many revisions in between that might have been important by writing this article, but are no longer important once the new version of the article is published actually. So basically when that article goes from draft stage to published, or they take an existing article, change it again, and it goes back from draft to published in that. So all of those versions, at least, for example, in the content preview system, the workspace, it could be implemented as well. We automatically garbage collect because those are no longer important. So one of the things we found in terms of Drupal, how Drupal does things, and how a tool like Flip or Google Docs does things, is like, it's very, very important for the user to be able to publish something. to click on a button and to say, this is a version I want to save. This is something that doesn't need to be auto-saved, etc., etc., etc. This is a state I really want to save, this state I want to preserve, this is a state I want to publish. And by changing this over to have versions not be every keystroke is like a new version in that, and then you basically compress them a little bit, or but really by saying, when I click publish, a new revision is created. This allows this kind of garbage collection to feel much more natural in that. Of course, you can still like hold a backup, like you say, hey, for the old revisions, I still keep them for 30 days, for 90 days, or whatever your data retention policy is. That's a possibility. And that's basically what we're doing for the content preview system in practice. That if an editor says, I've written something, I've published it, but in between I had something, I need that back. Okay, 90 days, you can have it back afterwards. Probably not relevant anymore. Can be a year, whatever. It depends also how much data space you're willing to sacrifice, because that's basically always the same thing in that. That is a trade-off between having all the history and using all the space. But if you're really paranoid, you could also take the YJS document, put it on the tape. Tape seems to still be the cheapest way to store data right now. So you could do that. I mean, no one would hold you from that Kevin could hoard all the Wikipedia articles that users ever create for all of history of how humans interact with YJS dev. But maybe not. The main takeaway here is basically versioning are not just arbitrary, like every 300 milliseconds or whatever, but they're deliberately created by the user. And whenever there's no version created, we can, at least after some point, garbage collect them. And this solves a huge problem of data editing in general, even in that. That's overall, you want all history, but on the other hand, you don't.
Right.
That's a very good illustration of that conflict. No pun intended, by the way. I think that this is very interesting. We're running out of time, though, so I wanted to jump to one final question just for our audience who might be considering adopting YJS and YIndexedDB and all of these this incredible suite of technologies. Are there any companies already using YIndexedDB for offline editing? Are there any people out there already making use of this in production?
So the new implementation of YIndexedDB, which is created for version 13, it's pretty fresh. I'm not aware of anyone using it, except the YJS dev website. But for version 12, there was a similar project, YIndexedDB, but for the previous version, which is now pretty old. But I know a lot of people who used it just by default because it made their website faster and it didn't really cost anything. It works the same way. It has a different API, but now you can do more stuff. And yes, there are at least 2 companies I know who use them. I'm not sure if I can name them right now, but yeah, basically it's just a progressive enhancement and you should always use it if you can. Although I want to add, I'm not aware of any offline only or offline first application that uses YJS and YIndexedDB. And this is something that I would be interested in seeing a lot more. And also I want to add, YJS.dev is completely offline first. Just visit it while offline. There's no difference in the online and offline version.
Wonderful. And for people who want to dig into the code and report issues and look at some of the way that that YJS actually works, where can they find the source on GitHub?
Just go to GitHub/YJS. This is a GitHub organization for YJS. There are lots of repositories. YJS-demos should be your go-to resource for figuring out how to create examples, how to use WebRTC, IndexedDB, ProseMirror, like all the things are there. There's a lot of documentation in the README on YJS/YJS. And yeah, if you're interested in the inner workings, watch our previous webinars. And also there's a paper at the end of the README. yeah, please come visit us.
Well, I know I'm going to be telling all my friends, as I have been every week, that we've been able to have you on the show, Kevin, to try out YJS. In fact, I'll probably tell some of my colleagues at work later today that we should be looking at YJS. With that, unfortunately, we're out of time, but I'm really glad to have shared this time with our good friends on the Tag1 TeamTalk show today. By the way, we post all of these talks at tag1.com/tagteamtalks. All the links that we mentioned today, including all of the GitHub links and all of those examples that we mentioned, are going to be posted online with the talk. And as always, if you enjoyed this episode of Tag1 Team Talks, we'd love to hear from you and get your feedback about things you want to hear about. Please remember to upvote, subscribe, and share it with your friends and family. And as always, if you have any topics you want to hear about or anything you want to talk about on the show or hear about on the show, please write to us at tag1consulting.com. And I want to thank Kevin, Michael, and Fabian today, three of my dear good friends on the show. Thank you so much for your time today. I learned a lot. I hope that our audience did. I'm sure our audience did as well. And we'll see you next time on Tag1 Team Talks.